Mr. Clare for Clare Maths, SQA National 5 Maths 2025, Paper 2, full solutions, and hopefully you find this useful. It took place on Wednesday the 14th of May, 10:30 to 12 o'clock. Okay, let's just get started straight away. SQA National 5 Maths 2025, Paper 2, Question 1. The number of visitors in a zoo in 2024 was 118,750. The number of visitors is expected to increase by 4% per year over the next 2 years. What's the number of visitors in 2026? So we'll just do 118,750 times 1.04 to the power of 2. So my calculator, 118,750 times 1.04 squared is 128,440. And we're done. SQA National 5 Maths 2025, Paper 2, Question 2. Shop sells footballs in the shape of a sphere with diameter 21. Calculate the volume of a football, 3 significant figures. So start of the exam paper, volume of a sphere is 4/3 pi r cubed. So I need to work out my r. Well, r is 21 divided by 2, which is 10.5. So it's just 4/3 times pi times 10.5 cubed. Get my calculator as usual. 4 divided by 3 times the pi button times 10.5 to the power of 3 is 4849.048. I need to round that to 3 significant figures. So that's 4, 8, cut in here, 9 goes up to 5 then, and 0. 4850 centimetres cubed. And we're done there. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code CLAREONMATHS, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code CLAREONMATHS. Click the link to order now. SQA National 5 Maths 2025, Paper 2, Question 3. The mass of one atom of gold is 3.27 times 10 to the minus 22 grams. The mass of one atom of carbon is 6.1% of the mass of an atom of gold. So we know the mass of an atom of gold. We have to look at the mass of an atom of carbon. So it's just 6.1% of 3.27 times 10 to the minus 22. So in a calculator to do that, I just do 6.1 divided by 100 times 3.27 to the power of minus 22. And it gives me an answer of 1.9947 times 10 to the minus 23 grams. Now I could maybe round that if I want to about 2 or 1.99, but unrounding it doesn't make a difference because you're not getting asked to round. So we're done there. SQA National 5 Maths 2025, Paper 2, Question 4. The weight in kilograms of a survey of rugby players in Scotland are shown, meaning standard deviation. Start of the exam paper tells you, I use this formula. The standard deviation is the square root of the sum of x minus x bar squared over n minus 1. Now you can use the other form if you want, but that's the one I use. So I just write x minus x bar squared, 93, 103, 99, 105, 88, 106, and 92. So the x bar is the mean, so I add all my numbers up in a calculator as usual. 93 plus 103 plus 99 plus 105 plus 88 plus 106 plus 92. And divide by how many numbers there are. 1, 2, 3, 4, 5, 6, 7. 98. So I'll take away 98 from each of the numbers in the middle. So 93 minus 98 is minus 5. 103 minus 98 is 5. 99 minus 98 is 1. 105 minus 98 is, well, that's 7. 88 minus 98 is minus 10. 106 minus 98 is 8, and 92 minus 98 is minus 6. You then square each of the numbers you've got. So that's 5 squared is 25, and 25 again. 1 squared is 1, 49, 100, 8 eighths is 64, 6 sixes is 36. Add them all up. 25 plus 25 plus 1 plus 49 plus 100 plus 64 plus 36 is 300 exactly, I get. So our standard deviation is the square root of 300 over 1 less than the number of numbers you had, which is 6. So that gives you the square root of 300 over 6, 7.07. So just to be clear, our mean is 98 kilograms, and our standard deviation is 7.07 kilograms. Just check that. Yeah, 7.07 is fine with me. Part B says, a sample of rugby players in France, and the first one was about Scotland, have a mean weight of 105 and a standard deviation of 5.9. Make 2 valid comments comparing the weights in Scotland and France. So we've got from Scotland, it's 98 and a standard deviation of 7.07 kilograms. And for France, our mean is 105 and the standard deviation is 5.9 kilograms. So we can then just say that comparing the means, on average, the weight of rugby players in, and let's just pick the biggest one, France, is more than Scotland. Is bigger, more, whatever, as long as you mention the weight. And I'll just write since 105 is bigger than 98, just to be on the safe side. And then comparing the standard deviation, that's statement 1. Statement 2, the weight of rugby players is, well, more consistent for a smaller number. So 5.9 in France, more consistent in France. Against Scotland, I'll just be very, very clear. Since 5.9 is less than 7.07. Now, the SQA used to need you to compare the numbers, and in recent years have not needed you to compare the numbers, so I'm just put it in just in case. But I wouldn't worry too much if you forgot to put the numbers in the comparing, as long as the statements are correct. National 5 Maths 2025, Paper 2, Question 5. Express this in the form x plus a squared plus b. Complete the square. Half the middle term. Still got 19. And then I do 5 5s is 25 and take it away. X plus 5 squared then. And 19 minus 25, well, we've got a calculator, guys. So if you can't do it, just check. Minus 6. And we're done there. SQA National 5 Maths 2025, Paper 2, Question 6. A party is made in the shape of a cone as shown below. The piece of a card is used, making the hat as a sector of a circle, centre C. The radius is 15. The angle ACB is 170. Calculate the area of the sector. Angle over 360 times pi times r squared, which is 15. So it's just a calculator again. $333.7942 or 333.80 centimeters squared. And we're done there. National 5 Maths 2025, Paper 2, Question 7. In the diagram, ABCDE is a regular pentagon. EFA is 65. We have to calculate FAB. FAB is a straight line, sorry. Calculate FEA. FEA. So we're trying to get to here. So first of all, pentagon. So I can do 360 divided by 5 to get the angle in the center. That is 72 degrees. Just use your calculator. So we've got 72 in each of the centers, but I'll just put one of them. And this will be an isosceles triangle. So I can do 180 minus 72. 180 minus 72 is 108. 108 divided by 2 then is 54. So we can get 54 degrees at the extremities. Don't need the other one, but put it in if you want. And we also know that this one's 54 then because of symmetry. 2 54s is 108, so I can now do 180 minus 108 to get this one here, because angles on a straight line add up to 180. That gives me 72 up here. And then finally, our angle FEA, well, angles in a triangle add up to 180, so 180 minus 65 minus 72. 180 minus 65 minus 72 is 43 degrees. And we're done there. SQA National 5 Maths 2025, Paper 2, Question 8. The diagram shows a cuboid relative to the coordinate axes. L has 0, 3, 12 and R has 4, 0, 0. Write down the coordinates of M. So where's M? M is up here. So I start at 0. I need to go along to here first if I'm going to M. So that's 4. I then need to go in this far. Well, it's a cuboid. It goes in that much, which is the same as going in this much, which is 3. And then I need to go up to the same place as L is. So up to 12. Because the last number on L is 12. And we're done there. It then says, calculate the length of the space diagonal OM. So in other words, it wants us to calculate the length from here to here. Now, the easiest way to do that is by vectors. You get 3D Pythagoras, because if that's 0, 0, 0, we could go that times that, get the Pythagoras and do loads of stuff. But since it goes from O, which is 0, 0, 0 to M, then for part B, it's really, really easy. 3D Pythagoras with the coordinates, coordinate M. So the length from O to M is simply the square root of 4 squared plus 3 squared plus 12 squared. And the reason that works is O to M is like a vector. So the vector line of O to M, since O is the origin, is 4, 3, 12. And you're working out the size of O to M basically, which is basically the same as doing the magnitude of it, the size. And this is how you do the magnitude. 4 squared plus 3 squared plus 12 squared is square root of 169, which is 13. 13 units. We don't know how long that is. Is it centimetres, metres? Doesn't actually say. So 13 units. And we're done there. SQA National 5 Maths 2025, Paper 2, Question 9. Change the subject of the formula to K. So where's my K? It's right here. So I need to add 3C first. B plus 3C equals a quarter KC squared. Now I get rid of that quarter, so I'll times both sides by 4. So 4 bracket B plus 3C, or 4B plus 12C, equals KC squared. Now I need to divide by C squared to get the K on its own. 4B plus 3C all over C squared. Or in other words, K equals 4B plus 3C all over C squared. And we're done there. SQA National 5 Maths 2025, Paper 2, Question 10. On Bob's lorries are 7 stacks of paving slabs and 3 stacks of edging blocks. The total weight is 2,400 kilograms. Let P be the weight of a stack of paving and E is the weight of a stack of edging. Write down an equation for P and E. Well, that's easy enough. 7P plus 3E equals 2,400. Part B. Imran has 3 stacks of paving slabs and 4 edging blocks. The weight is 1,300. 3 paving, 4 edging equals 1300. That'll be different for part C. Beth has 6 stacks and 5 of paving and 5 stacks of edging. What's the total weight of her stacks? Well, if I work out the total weight of a P and an E, I can just sub into whatever her equation would be. So that's my goal for part C. So I've got 7P plus 3E is 2400. I've got 3P plus 4E is 1300. So I can times this one by 4 and that one by 3 to get 12 in the second position. 4 sevens is 28P, 4 threes is 12E, and 4 times 2400 is 9600. But you can use a calculator if you want. 3 threes is 9P, 3 fours is 12E, 3 nothings is nothing, 3 threes is 9, 3 ones is 3. Take away. 28 minus 9, so that's 19, I think, but if you're never sure, calculator is always worth. Yep, 19p equals, now I can't be bothered, 9600 minus 3900, 5700. So p is 5700 over 19, which is 300. And now I need to work out my E, so I'll sub into an equation. So I'm just going to pick this one. 3 times P, which is 300, plus 4 times E equals 1300. So 900 plus 4E equals 1300. So I take away 900, well that gives me 400. And I divide by 4, so that gives me 100. Now I always like to answer it just to be on the safe side. So the weight of a paving slab is equal to 300 kilograms, and the weight of an edging slab equals 100 kilograms. But I've not actually answered the question yet. If you've stopped there, you've missed something, because it does say calculate the total weight of stacks of paving slabs and edging blocks on Beth's lorry. Let's just make sure Beth's only got one lorry. Beth's got a lorry, Imran had his own lorry, and Bob had a lorry. So it's just Beth's lorry. So it's 6P and 5E. So for Beth, we can say her total weight is given by 6P plus 5E. So that is 6 times 300 plus 5 times 100. That's 1800 plus 500. That is 18, 19, 20, 21, 22, 23, 2,300 kilograms. And we're done there. SQA National 5 Maths 2025, Paper 2, Question 11. Two models are mathematically similar. The small model has 14 centimetres long, and the area of one of the wings is 24 centimetres squared. I'll just write that. Area equals 24 centimetres squared of something. The large model is 31.5 long. What is the area of the wing of the large model? Well, this is a scale factor. So the linear scale factor, I want to find it in the big one. So I do the big side divided by the small side. Now I don't need to work this out, so I'm just going to leave it like that. That means that the area scale factor is 31.5 over 14 all squared. So to get my new area, I take my area scale factor and times by my small area. So the area is equal to 31.5 over 14 all squared times 24. And that's just a calculator job. Brackets, 31.5 divided by 14, bracket, squared, just press equals I think, times 24, 121.5 centimetres squared, and we're done there. SQA National 5 Maths 2025, Paper 2, Question 12. In the diagram, A, B and C represent positions of 3 checkpoints on an orienteering course. B is 250 east of A, C is on a bearing of 131, it's shown in the diagram anyway, and C is 200 metres from B. Calculate the bearing of C from B. So from B, I need to calculate going round that way to get back to C. Don't worry if you couldn't do the whole thing, but let's just start it from where we can start it. 90-degree angle there. There must be one there as well then, so I can do 131 minus 90. That's 41 degrees, and that gets me 41 inside the triangle. So now, is there any other angles I can work out? Well, not quite, but I can do the sine rule because I could do this pair go together, and I can't find anything with this and this, but I could find this angle here using the sine rule. Now, if I knew that angle, then angles in a triangle to 180, so I could get this angle, which means I'll get the other side. So that's going to be my approach, using the sine rule. So let me just mark the angle I'm focusing on. I'm marking this one. I'll just call that X. So we have got 250 goes with that one. 250 over sine X equals 200 goes with this one. 200 over sine 41. So we rearrange that. That times that. 250 sine 41 equals that times that. 200 sine X. And we write that again. 250 sine 41 equals 200 sine X. Divide by the number in front of sine. So sine X is 250 sine 41 over 200. 250 sine 41 divided by 200 is 55.092, or about 55.1 degrees. So we know that's 55.1, so we can work out the other angle just by doing 180 minus 55.1 minus the 41 we already know to get 83.9. So our bearing, remember, was going all the way around here. Well, we now know that on the left-hand side of that, we've got 90 plus 83.9. Which is 173.9. So our bearing then is just going to be all the way around the circle is 360. We already know that bit, so we can just take away for 360. So our final answer is 360 minus 173.9. Which is 186.1 degrees. Or bearings are usually three figures, so about 186 degrees, but you'll probably be fine with 186.1 or whatever rounding you want. SQA National 5 Maths 2025, Paper 2, Question 13. Solve this equation. So, I've got 2 and 3 in the denominator position, so I think I'm going to times by 6 on both sides, because 2 times 3 is 6. There's other ways to do this, but that's my preferred method. So I get 6 5x plus 1 over 2 equals 6 fours is 24x plus 6. Simplifying this as I go, 6 divided by 2 is 3, 5x plus 1. 24 divided by 3 is 8, x plus 6. Expand the bracket. 15x plus 3, 8x plus 6. Move the x's to the left to start with, so that gives me 7x by taking away, plus 3 equals 6. Now move the 3, so I'll take away 3, 7x equals 3, divide by the number in front of x, 3 over 7, and we're done there. SQA National 5 Maths 2025, Paper 2, Question 14. The ride at a theme park car has attached to the end of a rotating arm. The starting position of the car is shown in the diagram. As the arm rotates clockwise, height meters above the ground. Each rotation is given by, there's our key thing, h equals 10 minus 8 cos x. Trig equation, where x is the angle. Calculate the two values of x for which the height is 13 meters above the ground. 13 meters, so I'll just write 10 minus 8 cos x equals 13, and I need to solve that. So I'll move the 10 first, this is your first sticking point, so the minus 8 cos x is staying where it is. Opposite of 10, which is opposed to the numbers minus, so that gives me 3, and I need to divide by minus 8. So I get minus 3 over 8, or 3 over minus 8, but I prefer minus 3 over 8. So now you do the inverse cos. And this is your sticking point. Don't do the inverse cos of a minus, because you get a wrong answer, because you're trying to do a cast diagram that only works for positive numbers. So I do 3/8 only. Shift cos 3 over 8 is 67.975, blah, 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 or about 68 degrees then. Cast diagram. So our cos was negative. So usually I pick A and C, but I pick the opposite. So it's S and T. So at S we do 180 minus the angle, 180 minus 68. And at T, we do 180 plus the angle, 180 plus 68. Two answers. 112 degrees, 248 degrees, and we're done there. SQA National 5 Maths 2025, Paper 2, Question 15. In the diagram below, DG and GE are R and S, and they're shown in the diagram. But it also says that DE is 3EF. So in other words, here to here is 3 of here to here. I have to go from G to F. I need to go there. Now I can't go that direction, so I could go up here, but then I'll need to know that one. Or I could do some funky thing like go up here and go all the way along, but I still need to know that one. So I'm going to have to work out D to E in some way, or E to F. So I'm going to do D to E. To work out D to E, I could do a journey of starting at D. I could go down R, and then I could go up S. So we know that that's R plus S. So D to E is R plus S. And we know that E to F is a third of that, because D to E is 3 of E to F. So E to F is a third of D to E. And now I can find my G to F. G to F is just going to be starting at G. I need to get to F, so I can go up S, plus along here, which is E to F, a third R plus S. Expand the bracket, S plus a third R plus a third S. S plus a third S is 4/3 S, say, plus a third R. And we're done there. This is Mr. Clem from Clem Maths. Today we've done SQA National 5 Maths 2025 Paper 2. Hopefully you found that useful and helpful. Take care, stay safe, and goodbye.